Morning, guys. I wanted to talk to you today about our quadratic formula and kind of go through one full problem all the way to the end where we have x equals two different values. Okay. A reminder again, the quadratic formula is doing the exact same thing that we did with factoring. It's just a more powerful way to do this because if it's something that we can't actually factor with our normal factoring setup, this can solve it. Okay. It'll get us those decimals because normally we can only factor if we get whole number answers. The quadratic formula deals with our x values when they're not exactly a whole number in between those whole numbers. Okay, so it gives us those decimals sometimes. So I kind of wanted to walk through a pretty basic one here. Pretty much any problem they give you, whether the numbers are big or small, it's going to be the same process, and your calculator is going to take care of most of the work. Which is the really nice part about this is the calculator does the majority of the work for you as long as you type that in correctly. Okay. So first thing about our quadratic formula is we have to be able to label our A, B, and C. Okay? So our A, B, and C, again, our quadratic formula, the normal standard form, again, this is what we always want to have our problems in before we get into our factoring, is it's got to be equal to 0, and we have it our x squared, x, and then our constant. Okay? Largest exponent to smallest exponent. Okay? So then here, our A value is whatever number is with our x squared. Right now there's nothing here, so we treat that like there's a 1. Our B value, so I'm just going to put an A underneath of it. Our B value is always paired with x, so I know this is my B. My C value is always by itself. I personally like to write these off to the side because when I go to plug things in, it's nice and easy. I don't have to try to go back and forth between the x's. Again, that's completely your choice if you'd like to do that or not. Okay? We're going to plug this thing into our quadratic formula. So I'm going to write this off the side. Again, you won't need to memorize this, but this is something you need to know how to use. Opposite b plus or minus the square root of b squared. Put the square on the outside. Minus 4 times a times c all over 2 times a. Okay? Again, we're just substituting or replacing those things within each position of our variable. That's why yesterday we practiced just plugging things in, essentially substituting in our numbers for our variables. That's so that today, when we get to plugging these in and actually get into our quadratic formula, we're able to plug it in the correct spot and get to our solution. Okay? So then here I have opposite b. So b is positive right now, so opposite b says we're going to make it negative. So I've got negative 3 plus or minus. Under the radical, I have my b value, so it's 3 squared. Minus 4. Our a here is a 1, so I plug in a 1. Our c here is negative 4, so I put negative 4. All over 2 times our a value, which is 1. Okay. Again, as long as you can identify your a, b, and c and put them in the correct spot, we're okay. That's kind of the most difficult section for the most part that we're dealing with, is just making sure they're put in the correct spot. Okay. After this, you're going to take your calculator and you're going to do what's underneath of our radical. Okay. So if you type this in to your calculator, 3 squared, again, you type it in exactly the way it is. 3 squared minus 4 times 1 times negative 4 would get you 25. So I'd have negative 3 plus or minus the square root of 25 over 2, because 2 times 1 is 2. For right now, if the number inside here, and the reason why I say just plug this piece in, if you get a negative value inside that radical, for right now, we're going to say it's not factorable at that point. Okay, or it's not, essentially we'd stop there and just say that's a non-real solution. Okay, we deal with imaginary numbers in Algebra 2. When you have a negative value inside of the radical, that's essentially going to get you an imaginary number. We're not going to deal with that this year. So when that happens, you can just put non-real solution. Okay. But right now we do have a positive number, so I can say, all right, square root of 25. Okay, at this point, we can plug in square root of 25 into our calculator. If you do square root of 25, it gets you 5. So I've got negative 3 plus or minus 5 over 2. Okay, this is the part where it gets a little bit weird. Normally, once we factor, we have 2 parentheses. We split them up into 2 separate problems, set it equal to 0, and solve. This one, we're going to split it up, but it's going to be a little bit different. I kind of split them up and down. And the reason for this is I have this plus or minus. So it's saying I saw this, it could be a plus or a minus. We're going to do each of those different problems where one's a plus and one's a minus. So here I would have negative 3. The plus is on top, so I put the plus on top normally. Plus 5 over 2. Notice it's the exact same numbers, nothing changed about the numbers. I just put a plus there. Now when I write the second one, I'm going to have negative 3 instead of the plus. I'm going to put minus 5 over 2. Nothing else changed. The negative 3 is negative 3 for both of them. The 2 is still in the bottom for both and positive. The 5 is still a 5. It's just a plus or a minus. Okay? So then I will solve this. Negative 3 plus 5 is 2. 2 divided by 2 is 1, so I know one of my solutions is 1. Negative 3 minus 5 is negative 8. Negative 8 divided by 2 is negative 4. So this would be my two solutions, x equals 1 or negative 4. Quick reminder, what we're solving here is essentially where it crosses on the x-axis. So if I say, well, what does that actually mean, or where does that actually happen? Like, how would I see that visually? I would say that means on the x-axis where we have a 1, on the x-axis where we have a negative 4, that is where our graph is going to be located. Okay? Just kind of put it into context again, what we're actually doing here is finding those x values, those zeros, where it crosses the x-axis, so eventually when we get to our graphing, we're able to graph those things without too much trouble. Okay? Again, today we'll kind of practice this. Let me know if you've got any questions. Otherwise, I will see you guys in just a little bit.